Okay, for today, it's a review day for our test that's coming up for my kids. This test for Chapter 1 isn't going to happen until Monday, but this test, this is our big 1 day of review for the Chapter 1 test, which is basically on function notations, and there's some probability in there, and there's also those shadings, so you really have to totally understand union versus intersection. Okay, those are the main big things. The notations also included something that my sub taught, which was those complicated ones like this, where x is greater than 5 is like intersected with y is bigger than or equal to 8, that kind of thing. That's under the topic of notations, but you'd have to be able to, make a picture of what that looks like. Graph the right answer set. Okay. All right. So what I'd like you to work on, if you haven't already got this done, is I'd like you to find the distance between these 2 points, and then the midpoint, and then the equation of the line that would go through those 2 points. All right. So there's some things to work on. Again, for those of you that are done with those 2 points there and you got all of those things, you can start this one and start making a little picture of what you think that graph would look like. The graph that would encapsulate these points. All right. Okay, so the distance for this puppy would be the square root of 5 minus 2 squared plus 3 minus negative 8 squared comes out to square root of 130. I'm going kind of fast because I already explained that off the video, but just want to show people that were that hadn't seen that yet, how to do the distance. Now, the midpoint is the average of the x's, comma the average of the y's. That'd be 7 halves and 5 halves, also known as 3.5 and 2.5. Raise your hand if you had that. Okay, awesome. That was just the average of the x's, comma, the average of the y's. That's how you find the midpoint. And the last one is the equation of the line through them. First thing I'm going to do is find the slope. And the slope is the y's over the x's. And then I'm going to subtract the y's, divide it by, subtract the x's. Now, the order of this one does matter because I'm not going to be squaring them. So I always go this way. That minus that, so that'd be negative 8 minus 3 makes negative 11. And that minus that, 5 minus 2 is 3. Negative 11 thirds is your slope. Raise your hand if you had that right. Good. Then there's 2 options, 2 ways you can play this now. You can either say y equals mx plus b, and you're mostly done. But then you got to figure out what b is. How do you do that? By sticking a point here and here and solving for b. That's a way. How many of you did it that way? There's usually a few people. Okay, so it's like 4 people did it that way. That works. Or I like this way. If you multiply this slope formula by the denominator, which is always a good idea to clear the fraction, I'd have x times x minus 1 minus x in here. And look, that's that slope formula. Now, you could argue about where the sub 1s should be and stuff, but it doesn't matter that much. Y minus y sub 1 equals m times x minus x sub 1. There we go. And I did it that, or I do it that way usually. How many of you did it that way? And it's almost the rest of the class. Okay, good. Now, that and that are a point. I pick either point. Which one's easier? The one that has no negatives. I would have picked that point. X is 2, y is 3. And now the slope was a negative 11, what was it, thirds? Negative 11 over 3. Okay. Then the final answer is y minus 3 equals negative 11 thirds x minus 2. If you multiplied that all the way out, it's kind of like the people that did the y equals mx plus b form. It's totally okay if you multiplied that all the way out. But that's also totally okay to leave it that way. That's a good form. And you're going to see that more often than you're going to see y equals mx plus b form. From here on, that's used a lot. It's really important to know this formula, the blue one. If you don't know it, know it. You need to learn that one. Okay, good. Covered a lot of stuff. Now, how about this black one? This is directions to give you a set of points. X comma Y. So that's why I'm making an x-axis and a y-axis. And then I'm going to say, wow, that was quick. Right there. Thank you very much. Okay, cool. So the x ones are bigger than 5. Here's where x is 5, let's say. And if it's got to be bigger than 5, I hope you used a dotted line. Yes, I would be that picky on the test. If it was not dotted, I'd have to mark it wrong. At least partial credit. Okay. Next, where is it about that line? Is it to the right of it or to the left of it? It's the right of it. So I'm going to shade to the right of that line. Now, that's all the points, x and y, where the x is bigger than 5. Now I got to narrow it down a little bit. Where does that intersect with y is greater than or equal to 8? Imagine this is the spot where y is equal to 8. I'm making it a solid line because it says or equal to. And then I want bigger than that. Well, that's everything up here. If you've learned what these symbols mean, that means where do they overlap? My final answer then would be only in this area do they overlap. And so my final answer, just cleaning this back up again a little bit, is in this dotted line, and this being a solid line, in that answer right there was it. Raise your hand if you had that one right. Awesome. Okay, that's a lot of the stuff. It summarizes a lot of the stuff. Is that all the stuff? No. I was letting you guys ask questions. What else do you remember doing that you think could possibly be a topic for this next test? Yes. Symmetry. All right. So you just learned last night about how to test something for symmetry. Let's say it's that. I have no clue what that graph looks like. But I could kind of figure it out with a few things. Like I could find its x-intercepts by setting what? Y equals 0. I could find its y-intercepts by setting what? X equals 0. I could figure out its, let me think. Well, I could figure out any point I wanted by just making an XY chart. That's one of the most powerful things is just find a whole bunch of answers. So I'd like you to find a few. Pick a few points and just stick them in. Easiest for me anyway to always stick in the X number and then solve for Y. But it can go the other way around. You can stick in a Y number and solve for X. That works. In this case especially, I think it'd be a lot easier to pick X's. So what's a good X to pick? I don't know, 17? No, it's huge. So why not pick something? 0 is a great idea. Besides, by picking 0, aren't you also finding the what intercept? The y-intercept? Yeah, you're kind of killing two birds with one stone there. So that's a good idea. And then maybe you should try y equals 0. And then see what the x is. Then maybe try x equals 1. Maybe try x equals -1. Find those points. There's 4 of them. They'll all be good points. Pause for a second while you find 4 points on this graph. Okay. When you stuck in 0 for x, you should have gotten 0 equals 4. That's weird. Does that mean I did something wrong? That means there is none. Whenever you get a false answer, that means there's no solution for that, which means there is no place that this graph would touch the, well, was I finding the y-intercept? I said x equals 0, so that, yes, this was the y-intercept. And the answer is none. There is no answer for that. What if I had gotten a true statement? Just to clarify, there are answers like that. 2a plus 5 equals 2a plus 3 plus 2. Obviously, that's the same thing, right? What if I got, when I subtracted the 2a's, I got 5 equals 5. If you get a true statement, you have found something that is not never true. It's what? Always true. All real numbers. So either there's such a thing as a no answer ever works, no solution. There's also a every number in the world would work. If you think about this, 2a plus 5 equals effectively 2a plus 5. Anything you put in will always work. That is also a possible solution. Is instead of no solutions, everything works. All real numbers is the solution. Okay, so when you get a false answer like that, you can just say none. All right, how about setting y equal to 0? That's a lot easier. In this case, if I set y equal to 0, I'm going to go put a 0 in here, and then it's just what's left is x equals 4. Then 4, comma 0 is a point on this graph. Raise your hand if you had that. Okay, good. And the next step, stick in a 1. Put a 1 here. Oh, wait, I'm putting it in for the x, sorry. Undo that. I'm going to put in x is 1. And that solves down to y plus 1 equals 4. Subtract 1 from both sides. Y must be 3. Raise your hand if you had a 1, comma 3. Okay, good. I think you get the idea. Do you get the idea that if I graph enough points eventually, I'll be able to see where this graph is? All right. One tip for you, pro tip. If you ever want to check yourself on this and you're at home and you just want to check it, that's not easy to put into a calculator because the calculators always want to solve for y. But there's a graphing app you have on your iPad called Desmos. And Desmos could graph that. We tell you all the points. Now, you can't use that on your test. But if you ever want to check your work, Desmos is a very powerful graphing app. And you could just put that sucker in, and it would graph it for you, all the points. Okay? All right. So we know how to find x-intercepts, where y is 0. Y-intercepts, so where x is 0. We know how to find a bunch of points, and we can graph it and see what it kind of looks like. Could you please shut that door for me? Thank you. Now, I'm going to do those 2 tests, or 3 tests. This is the test for does this thing have a certain kind of symmetry? Except x comma y, putting that into the equation would do absolutely nothing. It doesn't test for anything. If I put in negative x comma y, it tests for what kind of symmetry? Y-axis symmetry. Because the y is the one we've left alone, so that's the one that you key off of. This means we were testing for y-axis symmetry. All right, so now I'm going to go back to that problem we just had, which was x squared y plus x equals 4. And I'd like you to test it for y-axis symmetry by plugging in the negative x and the y. I'll pause while you give that a shot. Okay, so here's how this one should have gone. You put empty spots where the variables are. This really is a smart way to go. Let me emphasize this a little bit more. It boils down to this. Do you get that that and that have different answers? One of them is negative, one of them is positive. So we're all about the details in this class. This is a complicated, like a negative can screw you up pretty bad in this class. So you gotta be careful. So when you put in a variable, you have parentheses implied. That's why it's really smart to put the parentheses there and then drop something into those parentheses. Okay, now that x, it used to be there, it's going to be replaced with a negative x, and the y is going to be replaced with a regular y. X with negative x, and there. Now I multiply it all out, and I see if it looks identical to the original. Negative x squared becomes x squared, y plus negative x, which I can say minus x equals 4. Is that identical to the original? No, and therefore it does not have, which kind did we just test for there? Y-axis symmetry. All right. Would you please test for x-axis symmetry next? Test this for x-axis symmetry with a different rule that you should be able to figure out. Test for x-axis symmetry. Crystal, what's that rule that you're using? Excellent. X comma negative y. All right. Empty spots. Tell me what to put where. First one I put. Next one I put. Next one I put. Excellent. Multiply it all out. What's this one come to? I'm going to throw the negative in front because we usually would write it like that. And then keep going. All right. And now if you're not sure, if there's lots of negatives, I want to warn you about this. First of all, is your gut feeling that these are the same or that they're not the same? They're not the same. Just an FYI though, if there had been a negative everywhere, do you get that would have actually been the same as the original? Because you could have multiplied it by -1 and turned it all back to positives, and then they would have been the same. But if only one thing has a negative where the others don't, then yeah, that's not. But if all the signs are opposite, that's the same thing. Okay, cool. So we just figured out that's not the same, and therefore it does not have x-axis symmetry. Well, then it must have the other kind of symmetry, right? No, there's a lot of graphs that don't have any kind of symmetry. Okay, but what is that last test? Negative x and negative y. So I'm going to just do it quick. I'm going to put a negative here and a negative there, and then I'm going to rework this out and see if it has the last kind of symmetry called origin symmetry. So this becomes negative x squared y, negative x equals 4. Oh, if that one would have had a negative, then it would have actually been equal to the original because they would have all been opposites. But two of them have a negative, one of them doesn't, so it's not the same as the original. This one had no kinds of symmetry. Okay, there, we've covered, I think, everything that we taught you. Now, I want to make this important point. This is honors pre-calc, so the tests are not just going to be one of the problems I did in class for you. Okay, a lot of times there'll be a little twist to it. Like, for instance, how could I make it fair, but yet not exactly the same as what I just showed you? You got to be able to handle slight differences in the questions. So, for instance, I never actually, when I went over what we just did, I never actually reviewed what origin symmetry would look like. So maybe the graph on the test is how you're judged for origin versus y-axis symmetry versus x-axis symmetry. Here's a picture of a graph. Could you do it still? I hope you could. If you couldn't, if you can't make the leap from what we did algebraically to graphing, then you might get that one wrong, and you might say, but that's not fair because you never did that one in class. If you aren't hearing me, there's going to be questions that I didn't do exactly in class. That's what makes this an honors class, is you got to be able to handle a little twist. Same thing for the ACT test that you take someday. The ACT test, why does nobody get a 36? I shouldn't say nobody. We had like 1 or 2 people last year, which is amazing. Most high schools never have a kid get a 36. Okay, we had 1 or 2 last year out of 800 kids. Why did other people not get 36s? On the math portion, it's not because they asked a really impossible math question. It's because they asked a weird one. It was twisty. They don't give you super high-level math. Like, you aren't expected to know Calc BC. In fact, no calculus even can be on the ACT. And we have kids in calculus in, like, 9th grade. So how come those kids don't get a perfect 36? Because they ask the questions in unusual ways. They twist them a little bit. So don't be surprised to see that on your tests. You have to be able to expect the unexpected and roll with it and try to figure out. We've told you enough that you can figure it out, but don't expect me to do a practice problem of every kind of problem that's on the test. That's not going to be how this goes. That would be how a regular class would go. Usually in regular pre-calc, every kind of problem has been done, and then they test you on one like that. In honors, we'll have some that we did, but there's some that we didn't. And you have to be able to make the leap. Okay? All right. So now, I'm going to pause for a second while I figure out how to best spend our last few minutes here. Go. So, had some nominations of types of questions kids wanted to see. let's do another one of these. X comma y, where, actually, I'm going to do, yeah, I'll just leave it that way. It's fine. Where x is less than 2 union with y is greater than or equal to 3. Try to figure out which points would satisfy those directions. All right, this is a little add-on, not the same question. I'll use a different color. I'd like you to tell me what the graph would be for that. Okay, how could you graph that? And then thirdly, somebody asked about another one of those Venn diagram questions, so I'm going to do A, B, and C. And I'd like you to see if you can figure out where not B, union C would intersect with A. Hookah. I'll pause for a second while you guys give those three a try. Okay, this first one, here's x is less than 2. That's where x is 2, and I put a dotted line there because it said less than. Hopefully you use dotted. And I go less than 2 shades this way. Now notice it says union. That means not where these things overlap, but where everybody who got an invite is part of the answer. So here's where y is bigger than or equal to 3. Let's say this is where y is equal to 3, and bigger than that is above it. Again, if this had been an intersect question, the answer would have been here. But this is not an intersect question. It's where are the points that got an invitation. Okay? So the only thing that is not the answer then is that area there. Okay? So the final answer is leave everything shaded. Everything that's shaded is your answer, so there. I don't need to double shade it or anything. Any questions about that one? Okay, next one. Graphing this. Okay, what if I had -1 to 8, on a graph, and I said -1 works, I fill it in, all the way up to 8 doesn't work. There we go. Do you get how we might twist things by going, okay, now that union with a different set on the number line? We haven't done many of those, but that's a way we could test you on the union symbol. What if this was unioned with another group that's like 0 to 7? You'd have to figure out where was it overlap or where all are included? That would be an example of twisting it a little bit. We haven't done much of that, but you could see where they'd overlap. So watch. Here's 0 to 7. Oh, wait. 0's here to 7's here. And where would everybody who got an invitation be? Well, these blue guys got an invitation, but so did all the people out there. So some got 2 invitations, but that doesn't matter. If it's a union, the final answer would have been the same, actually, because it would have still been from here to there, but not there. Okay, now this, not B. I'm going to put dots where not B is. Those are all areas that are not B. Okay, union with C. Union means a big group, so I'm going to just keep using the same color because if you get any invitation, you're coming to the party. Okay, so here is C. All the C ones now just got invites. These guys got a couple invites, but it doesn't matter because it's a union question. All right, now I got to see where that overlaps with A. So now I'm going to send out A invites. I'll do those in green. Here's A inviting people. Now, the only things that are the answer are things that got both kinds of invitations. So, kind of like a Pac-Man. That was your answer. Raise your hand if you had that one right. Excellent. Okay. Next is probability. Let's say I had 70% chance of that, 10% chance of that, 10% chance of that, well, you'd obviously know what the last group has to be, right? Because it has to add up to a total of what percent if it's a probability one? 100%. So if that's 70, 80, 90, then what's this got to be? 10%, okay? What if I said, this is piano, owns a piano, this is owns a dog. What's the probability of not piano? Well, here's piano, here's not piano. Those two together, so 0.2. What's the probability of not piano intersect dog? Well, where does not piano intersect with dog? Here's not piano. Here's the ones for dog. Which one got both invites? There's your answer. Okay, you ready for a test on Monday if I don't see you tomorrow? If I see you tomorrow, we'll talk a little bit more. Bring your little cards back next time, please, or I'll have you make a new one. Have a good day.
Thank you.
See ya. Bye-bye. Thank you. Take care. Yep. Bye-bye. Take care. See you, Stephen. See ya. Bye-bye. Have a good day. What? I actually did. Cool. What? Oh, no. Your grade just went down. Tragically.
My first star was wearing, she's wearing a Axis jersey, and I said, we need to change that to the card.
Oh, especially hard.
Just need to change it.
Yep, we had Favre. Say that again?
Oh, sorry. Do you know how
Oh, I do. Sadly, they did not make it, but it's okay. They know that they were close to making it, and that makes it especially hard because they'd understand. It'd be easier to take if you had botched it. But on the positive side, they did feel like they had a good final performance. You know what I mean? Like they can't be mad at one guy who screwed up choreography, or you know what I mean? Like there was nobody had to be blamed for something going wrong. It's just they weren't quite good enough. And considering it's national contest,
I know they made it pretty.
yeah, they did. They did. So yeah, they're pretty. I'm pretty happy for them. Hey, what's up? Yes, you may. No problem. The test? Excellent. I'm glad to hear that. So I'm going to hand them back today, and you're going to have a chance to start the process. So the process includes you doing a redo of the problems you got wrong. That's your first step, is do corrections on the test that you kind of botched. So you can start that in class. It always has to be on a blank sheet of paper. That'll get stapled to the other test. So don't write on your original test. We want to leave that same when we know what you actually did the first time. Then you do corrections, and that's our start. And the next step really is, if I have extra work that I need you to do, I'll assign it. The only thing I'm going to ask you to do is show me that you're done with version 2 of the top 20 before you take this retake, because that's good practice. The stuff that's on there will help you. Okay? So that's the last thought is, if you want to really get better in here, learn those top 20 things. Take the time. If it's this weekend, set aside an hour to go over, learn some from some videos. 1 hour can seriously patch I bet you could improve your score by 5 points on the top 20 with 1 hour of extra practice. So do something like that this weekend, and then you can take it in the morning or after school next week. Okay? That's the plan.
So did he make it? Did they make it to the finals?
They did not make it. They were close. They know they were close, but it's okay. He's proud of. He said it well. We gave it all, put it all out there. Just wasn't good enough. And at least they don't have to be mad at anybody for like screwing up the choreography. I was paranoid that my son was gonna like, turn the wrong way when, you know what I mean, or just do something like that would mess it all up for everybody. Nobody screwed up. It was just not quite as cool to the rest of the United States as some of the other acts. Oh, and I've been recording this whole time. Wonderful.